Hello students, in this video we will discuss the variational principles. Okay, by the variational principle method of approximations we estimate the ground state energy, okay, or we can find the ground state energy for a system for which we know the Hamiltonians. The Hamiltonian is known, okay, while the wave functions is unknown, okay, or we can say the wave function is arbitrary, okay. And we can also find the first excited state and the second excited state and so on. For example, the potential for harmonic oscillator is equal to 1/2 kx square, okay. This potential is an even potential, or we can say this is a symmetric potentials, okay. This potential is symmetric about y-axis, okay. So we can find the first excited state and the second and so on using the variational methods, okay. The variational method of approximation is based on the variational principle. When we find the ground state energy for a system, then we know the variational principles to obtain the ground state energy, okay. Then according to the variational principles, the variational principle gives an upper bound to the ground state energy. Let's say this is the ground state, okay. But then the variational principle will find the upper bound to the ground states, okay, like the excited state, okay. And according to the variational principle, the ground state energy is less than or equal to the expectations of the Hamiltonian and any normalized arbitrary states, okay. This is the variational principles, okay. And here the expectation of H is equal to we take the any arbitrary wave functions as, let's say, psi and Hamiltonian and psi, okay. This is so simple. This is the expectation of H, okay. And if we take the minimum of the variational principles, then we will find the approximate value of the ground states, okay. Then the ground state energy is approximately is equal to the expectation of H of minima, okay. This is minimum. If we take the minimum of the variational principle, then we find the approximate value of the ground states like this. This is approximate value, so which is equal to this Hamiltonian of minimum, okay. And here the psi is or we can say that any functions, though arbitrary function, is a trial wave functions, okay. And this trial wave function is should be normalized, okay, and quantum mechanically it is acceptable, okay. This means that this wave functions is differentiable, we can take the x derivative and continuous, and also the square integrables, okay. Then they are quantum mechanically acceptable, okay. And the trial wave functions, there is adjustable parameter, okay. For example, the Gaussian trial wave functions is psi of x is equal to a into e to the power minus b and x square. This is the Gaussian trial functions, okay? And here the a is normalization constants, okay? While v is the adjustable parameters. Okay, if we take the minimum of the variational principle, the variational principle is this: the ground state energy is less than or equal to the expectation of h for the any normalized arbitrary states. Okay, but then if we take the minimum of this Hamiltonians, then this is approximately is equal to the x ground state energy. Okay, let's say here the ground state energy is this. Then if we take the minimum of this Hamiltonian, then we will get very close to this ground state. Okay, and let's say and the another one is here, then this is minimum, then we will get this energy rather than this, okay, because this is a minimum. Okay, and we minimize this Hamiltonian with respect to this adjustable parameters. Okay, if we minimize this Hamiltonian, then we with respect to the this adjustable parameter. Okay, and the next video we will prove the variational principles. Okay, thank you.